Right, folks, welcome. It's about 30:30, well, in South Africa, that is. And I'd like to welcome you to today's webinar. I am Andre Jordaan. I'm a partner consultant at Pragma, and I'll be leading today. I love interaction, of course, so please don't hesitate to ask me questions. Even as we're going, I might pick it up and respond to you in time. Alternatively, I'll look at it afterwards. We're looking at an hour. Hopefully, if all goes well, I'll land this in 45 minutes and even, as I said, to take your questions along the way. But hopefully, it's a journey, and it's a journey which you'd like to go along with me on, and I'll tell you what about it. So let's start. And we're looking at a world where we believe we can get the CFO and the engineering manager to agree on a optimum stock level. So we're really looking at spares optimization, and we want these two parties to sit next to each other and say, yeah, we agree that that is the right stock level. And how can we do that? And maybe as a bit of my background, I am an engineer, but I do love the finance after a stint in MBA and a little bit in the financial world. And therefore trying to bring these two together, and I will show you how we're actually going to do that. But to start off with, what are we going to talk about today? We're going to start off by looking at, so what is the problem? What are the stakeholders? Who are the stakeholders involved? And what's their view upon it? And once we understand the problem well, we're going to unpack that problem. So, okay, well, what's in it? Why does it matter? Are there service offerings out there that's actually catering for that problem? And then we're going to journey on to, well, is there models that actually works? And lastly, I'm going to use a little bit of marketing opportunity to invite you to our spares optimization course, which is running in 3 weeks' time. So let's start. There's mainly three groupings of people when you talk about spares. And the first one is finance, the procurement department. They look at a full store of equipment that's holding or capturing capital. They want to reduce that capital through some kind of means. That's mostly the financial department. That's mostly the CFO saying, this is dead waste. How can we reduce this? Mostly when they don't find someone, inventory gets involved and they try and reduce that capital. Then you've got operations and maintenance departments. They want to do the job with the least amount of issue. When they keep spares under their wing, that's why they often have squirrel stores or book stuff against wrong work orders just to keep the spare, because they don't want to be hindered by not having the spare when they need to do a certain job, or they want operations to run and not be hindered by not having that spare. Nobody, of course, wants that. And then lastly, you've got the spares department, which is often overlooked by either finance or engineering, and they want to improve their environment. They want to remove the inefficiencies. Can we do this better? They want better processes, better systems. They want the people properly trained up to increase their efficiencies. I'd like to group this in two groups. On the one side, saying, well, we clearly have optimizing spare holding. How can we manage bringing down the capital, but at the same time also having the right spares and the right availability for operations and maintenance? So should we hold the spare? And if we hold the spare, what's the min-max levels? When should we order it? And how many of them should we order? That I'd like to frame as the optimization question, spares holding. How many should we hold? Secondly, we're also looking at this spares administration and how can we optimize that environment? Do you have the optimum spares processes to do reservations, identifications, ordering, procurement, receiving, storing, master data, system support, all of that? Now, today, we are going to focus a little bit more on one. Maybe in our next webinar, we can venture more upon number two, but today specifically is more focused on number one. Right at the end, I'll wrap these two together again. So looking at number one, the question is, well, how can we solve this conundrum? In many companies I get to, there's nothing there. But lacking anything, it's the guy that's going to shout the loudest. He's going to get the most spares, and that's what happens. I've seen it. Right? They just send a form. How many do you want? And then some people say what they think should be there. And of course, the guy with the most power, he gets the most spares. Now, lacking that, normally the CFO gets involved, and then he'll put up his hand and say, "Folks, who can help me to reduce capital?" And then inventory is mentioned, and who's the guys that knows inventory best? Procurement. So procurement comes along and says, we know all about inventory. We've got a model, and we're going to solve it for you. That's not normally what happens. Now, is it inventory? And I think that's where we should start off, just asking the question, is inventory just inventory? Are they all the same? See, main grouping of inventory is, to start off with, this raw material, right? If you're a mine, then it's the raw rock that you're mining. If you're building cars, it's all the components of the cars that you're looking for. Um, that's the raw material. Secondly, you've got work in progress. This is a car half built, or this is a stockpile halfway within the mine, or whatever industry, refinery. You've just created, maybe not slot, but this is something in a stockpile or in a tank on its way to final production. That's work in progress. And of course, that's not good either, because you spend money on it, but you can't sell it yet. And then thirdly, you've got stock. This is finished goods. Now you've finished your oil or your diesel or whatever you're going to sell. This is finished goods. Maybe you need packaging for it. So packaging is sort of part of production, but not quite, but it's there. And that's why it's separate on number 4. But all of those goods are part of production. You can sell it. And your whole company is aimed towards that production line. That's inventory. Then you've got MRO spares. This is maintenance, repairs, operations, supplies. There you've got maintenance material. These are lubricants, glues, welding rods, many others. You've got your spare parts. These are parts that's actually part of your asset, replaceable parts. Or it could be the whole asset that's rotable. All right. So all of them is linked to an equipment number or a function location in some way or form. Well, it should be, really. It belongs to one of them. Whereas oils and welding rods, they don't belong to a specific piece of equipment. And then you've got operation material. This is typically your cleaning materials, your ACCC kits. It could even be wrenches and tools that you need either for operations in production or in operations in maintenance. And already you can see, apart from the colors that's different, that MRO spares isn't quite the same as inventory. But let's first agree that in some way or form, they are the same. So you can see they both tie up capital. You want to reduce both of them. You don't want inventory too much, which you've already paid for, but you haven't, produced them. Or you've got inventory that's midway between production and it's not finished yet. You don't want to grow that too much. Just enough to reduce your risk adequately, but otherwise it's costing you money. It's tying up capital. So they all tie up capital. We want to improve all of them, sure. They need to be minimized and optimized. Why? Because they tie up capital. In that sense, they are the same. And to be able to do that, they need to be controlled, right? You need master data, you need stock accuracy, you need reorder min-max levels, physical storage, handling, all of those. Goods can spoil. Raw material can spoil sometimes. Finished products can spoil if they're not cooled adequately, depending on what you're producing. And of course, your material, that if you've got an electrical panel, can spoil as well if it's not stored correctly. All right, and they are subject to supply chain risk. This wasn't all that big an issue. Suddenly, you're looking at the state of Hormuz, and suddenly we all understand supply chain risk. But it's not new. This also happened a couple of years ago when the chips dried up for motor cars, and motor cars production had to stop there for a second because of that risk. So this isn't something new, and it applies equally to all inventory. So how are they different? This is the important part. Well, see, if you look at MRO space, they do not directly generate revenue, which means you don't buy them to sell them. So they're clearly not that important because they don't hold up, per se, the production line. Or do they? We'll see. The demand is irregular. Now, if you're mining, you're mining 30,000 tons a day. That's the throughput that you have, and the whole plant is built for that throughput. You understand it very well. Your demand is known well in advance, weeks and years in advance. I got guys building planes, and their Ford order book is a year in advance. So they truly understand the demand, but not in MRO spares. Something breaks, and suddenly you need something. and then you don't need it for 3, 4, 5, 6 years again. Demand is very small. If you're in the mining industry, you're mining tons of it. Or you're in the oil industry, it's a tanker that comes to you. If you're in the paper industry, it's tons of trees and paper pulp that's coming in. But here you're looking at an O-ring or 3 or 6 that you need. It's the small stuff, and then you don't need it for a long time again. Stockouts have asymmetrical consequence. This is huge, folks. That's one of the most important points. You might have, good example, we had an instance just around the corner where a bread factory stopped for 4 hours because they didn't have a number 6 drill bit. That's something this long. I have 3 of them actually in my garage next door, but they didn't have one. Stopped production for 4 hours. So the relationship between the cost of the item and the consequence of not having it is totally unknown. There's no relationship, absolutely, between its cost and what its consequence might be. Criticality in the MRO world matters more than velocity. Why? Because it doesn't have velocity, but it's extremely critical. And then, of course, you've got this repairable items. That's part of this inventory as well. And this is unique. You're going to take out a motor and you're going to rewind the motor and you're going to bring it back in again and use it for a second round. So there's this secondary sort of inventory loop that you buy in the same product that you had. And you need to keep track of it because you can't just rewind this motor 100 times. If you're going to recondition a motor, or gas burning engine, you're going to do it once, maybe twice. But we know that the reliability thereafter is so bad that you really want to keep track of it. So rotables is not easy, and it's not comparable to anything in the normal inventory world. Then you've got master data requirements, and discipline is vastly more in this space. Why? Because you've got thousands upon thousands of input items that you have to keep track of. Just a simple thing like a bolt that holds 2 pieces together. It's an M8 bolt with a hexagon screw nut. It's made out of stainless steel or mild steel with a certain plating, which got a certain length, etc. So these are it's from a certain supplier. Everybody's got suppliers, but it's really technical to specify this specific item. In that sense, a lot more so than your normal inventory. So to keep your master data accurate upfront and throughout its life cycle, a lot more effort. And then this last one, obsolescence risk is higher. Now, people would maybe like to argue with that, but that's an interesting one once you start thinking about it. You see, most industries, they're gonna build themselves the plant close to where the raw material is, right? If you're going to make paper, you're going to put your paper mill close to where the paper is in the mountains. If you're going to have a mine, you're going to build a plant right next to the mine. If you're going to build a car factory, you're going to build it close to the sea, and all the raw materials is going to orientate themselves close to you, so that the chair can be just there when the car needs it. Right, so all that raw materials is going to orientate themselves right next to you, right next to the ocean, so you can ship it. So your raw materials is always a lot closer in proximity, lead times being a day or less to get hold of it. Whereas if you're looking at MRO spares, most often I get to guys in Saudi Arabia, in Africa, and they're waiting 3 months just to get it through customs. And if you're and of course if you're not a public organization, but then you often have to wait weeks just for approval to order something. So, and because of that lead times being so different, your risk of obsolescence is a lot higher. Now, where does this come from? Well, I've shown maybe in a slightly different way. You're looking at raw materials as input. The demand is very well known because your production plan is well in advance. The consequence of a stockout is very well known as well. Stockouts usually means loss of production and or sales, and the consequence is well known. Then you might have finished goods. stuff that's completed now. It's maybe on the shelf. It's waiting to be delivered. And you understand demand. You can influence demand. If you're in marketing and you've got 4 Ps or 5 Ps in production and price and promotions, you can influence demand. And you understand the consequence of a stock out. At that point in time, the consequence of a stock out is very much related to the price that you're selling it for or you produce it for. It's well known. There's a relationship between them. But then you get MRO spares. The demand is driven by, and it's an engineering discipline. It's usage, conditions, or run to failure based. It's linked to your maintenance plans and very much influenced by breakdowns or the optimum life of the asset, which is not always well known up front. It's an engineering discipline and it can't be influenced. Well, it can, but you need engineering people to influence. Doing a promotion for a motor ain't going to influence his performance or his longevity. And then the consequence of a stockout is not known at all. Right? Stockout means loss of production or not. It might be that right next to this item is a massive big stockpile of 3 weeks, and as long as you repair or rather replace this component within 3 weeks, you have no loss of production. So there's no way of just knowing what the consequence of this stockout might be, but vastly different from the other two. Now, normally inventory models now comes to play because procurement comes in and says, well, we've got a model, we can reduce your inventory. And this is the model that they normally use. Very effective in their space, and it's as old as the mountains, I'd almost like to say. It works really well. The dilemma is once you apply this model to the MRO world, you realize that, oh dear, there's a big category that doesn't fit in here. And that's the stuff that doesn't move. So obviously, being very pragmatic, you just create another block and call it non-movers, and then everybody's happy because everything can fit into a box. I've seen this happen. People's happy, fits into a box. And they'll tell you how big each of these boxes are or not. You see, if you apply this model, this is a typical MRO world, right? They all look like this. This is what you see. Now, what you expect to see is these blue little dots all over the place. I mean, you want to see a lot here. This is ultimate, right? You want a lot in there. That's the goal. None of them's there. Now, if you know statistics, of course, you can make statistics work for you, right? You just need to zoom in a bit. So let's do that. We'll zoom into that red little block down there. I'm sure by then that yellow block will move down there and then everybody will be happy. And so that's what we do. We just zoom in. Oh dear. And then it looks like this. That didn't help at all. Now you can't zoom in further. I mean, if you look at these ratings down here, that wouldn't be sensible at all. This is how far you can zoom, and this model doesn't fit the data. By the way, I modeled the non-movers here on the left-hand side because most often clients won't see that. Why? Because they don't move. So they're not going to show on your graph. And so they go missing. You see, this model doesn't work for the data. Now, let's quantify the data. Let's make it real. This is one of our clients. Obviously, I'm not going to tell you who it is. But here you can see you've got stock value of 27 million. All right, 27 million stock value. And you can see on the left-hand side, here's the non-movers. They've got 13.5 million. That literally is half. Half of the total stock value does not move. Now, this particular client's got really good data. They've got 20 years of data. 13.5 million has not moved in 20 years. Let's look at stuff that moves a little. Well, this is the slow movers or the low movers. They move at maybe 2 per year. But you're moving 2 items per year. If you include those, then you're going up from 56% in total value to 80% of value. Right? So 80% of the value of your store, 80% of that moves less than twice a year. And this is but one client. I can show you many others that are exactly the same. This is the MRO world. It's not the same as the normal inventory world. The stuff doesn't move. Actually, you sort of don't want it to move because then you're consuming something that's not adding to the end product, right? The more life you can get out of this product, the better. The less it moves, the better. As long as your uptime's there, of course. So what we're saying is that 50% of the value of the stores doesn't move 80% less than twice a year. Spares moving more than 50 units per year, that's about 4 in terms of value, 4%, which means if you go back here, the value of applying this model to this space will be accurate for 4% of your value. Now, if you're happy with a model that only addresses 4% of your value, then good for you. But it doesn't work for any of our clients. So, punchline is the traditional method would be applicable to 4 to 10% of the value, and that's simply not good enough. And it doesn't tell you whether an item should be stored or not. So we're looking at a host of these items stored over there, 56% in terms of value, and this model can't give you any insight as to whether it should be held or not. It gives no insight. Let's look at some of the items in there. This is some of the random items. All right, here you can look at a mechanical seal, rubber O-ring, there's a gasket. And this is just once again demonstrating that if you apply the normal inventory methodology, it doesn't work. There's a calculation that determines what your economic order quantity should be. How many should you order at a time? If you apply that in this space, you're going to order 3 over there, which is grand. I mean, it makes sense. Order 3. Well, that's 30 years of product. In O-rings, you're going to order 59, 60. It's package. No, it's not a lot of money. Only dilemma is that's 830 years worth of O-rings. And so you can go on. So here's another issue whereby the maths for inventory doesn't work in the MRO space. It's simply not going to work. 70% of the data was wrong. So this is one of our clients where we viewed that 70% of the calculations was actually not optimized if you apply the normal EOQ formula. Total saving when it was optimized thereafter was 613 in stock value. That might not be a lot of money. That was about 2% of the overall stock. Let's be honest, not a lot of money, but it's some saving there. But the issue is this. You need to store 88,000 items, which is waste, which you shouldn't store. 88,000, which you need to keep track of. And bigger issue, some of the items have a shelf life. Most of those that I've shown you. They degrade, rubbers, oils, pipes, etc. And they will be put into your plant and they'll compromise your plant in terms of its availability, consequential damage if it breaks, etc. It shows how even the simplest of things, standard inventory models, falls short on. So the key points, the demand profile and the intent of the MRO goods differ significantly from those of others. The consequence of stockout is vastly different, and even the maths used to order items is not relevant enough. These factors alone render traditional supply chain inventory optimization techniques inappropriate and useless. That model is not going to work for you. It will apply to 10%. If you're lucky, 20% of your data, but mostly 5 to 10%. But that's simply not good enough. It ought not to be good enough. Now, what also happens is we get normal inventory clients coming to consultants or groups coming to our clients, and then they'll offer them KPIs. Oh, yeah. This is normal inventory KPIs, really relevant and really important for inventory. You can look at your turnover rate. What is moving? If you're selling stuff, you want to produce more of the stuff that moves because that's the demand. That's where the clients are. All right. But that doesn't apply to the MRO space at all. I mean, you don't want to consume more O-rings, not more than what you need. You don't want to consume more motors or any kind of spare or asset more than what you need. right? That's purely waste. So to now try and motivate that you want a higher turnover rate, that's ridiculous. Secondly, they will come with a consolidation ratio. That's very much from procurement, saying, we want a higher consolidation ratio. It's better for us. Well, the issue is, you're ordering items once or twice a year. And from a specific client, you'll be ordering something maybe once a month, once every 2 weeks. Now you want to wait 2 weeks or a month to order something and therefore extend your lead time? That wouldn't be smart either. This cannot be a smart KPI for the MRO world. Yes, for inventory, but not for the MRO world. So MRO spares look like inventory on paper, but they're simply too different. In practice, spares are more about risk mitigation. So if we think about risk mitigation, that's the center of asset management. Risk is probability times consequence. What is the probability of it failing or it happening, and what's the consequence thereof? You need to understand that for MRO spares if you want to be successful in reducing your spares. That led to us to other models. The first one is this AAA categorization model, popular in the mines. The dilemma is if you look at it in a little bit more detail, you'll find that this AAA, which is very grand, lots of work went into it, that is very much the same as this model. It applies to the stuff that moves. The stuff that doesn't move, that's on this right-hand block over there. End up with the same issue. Doesn't help. This leaves two other models. Now, the next one is the material criticality model. It's a very usable model as well. All right. There you're looking at what is the criticality of the asset to which the material belongs. That gives you some insight as to maybe how important this material is. There is a bit of an issue with that, though, because you see, this uses the probability and the consequence of a failure. So here you're looking at what is the probability of the asset failing, not the probability of the store item not being available. That's not the same probability. The consequence here is also if this item fails, there will be consequential damage. Other items fails as well. Furthermore, it'll have environmental impact. It will have people impact, injured people. But a store item not being available means you don't start up. There's no environmental impact. Well, could be, but it's in rare cases. All right. So there's no environmental impact. There is no people risk of or so impact. It's really production that's not starting. So the probability and the consequence that that model is using doesn't relate at all to the probability of the item not being available and the consequence of it not being available. So even though it's useful, it maybe isn't good enough. So let's look at a model that actually ticks all the boxes. That's this one. You model the whole plot. We can help you with it. Do it in AVSIM. We'll charge you lots of money for it. And because it's a really onerously big work. We have done it for clients. It works extremely well. It is extremely accurate. Why? Because here you're looking at what's the probability of this asset not being available or this component not being available, and what is the consequence? You know what the consequence is of that asset or that function location not being operated. The dilemma is very expensive. And therefore, Pragma asked ourselves, well, if that be the case, is there a Pareto example? Is there a Pareto principle whereby we can apply this model without having to go into the lengthy detail of modeling the whole plot? And that's why we came up with what we call the value-based model. In here, you're actually modeling the probability of the stock item not being available, which you actually determine, and what's the consequence of that item not being available. Not the consequence of the asset breaking. It's not the same consequence. The consequence of the function location not being able to start up again. And so maybe at this point in time, a poll would be realistic, relevant. Lisa, if you can run it for us. Folks, I'd love to know, in your world, Which of these do you run? Do you have a model at all and you have maybe a guy that shouts the loudest? Is it that you've got this adaptive procurement model? And folks, some of you might have permutations of it, so pick the one that's closest. You might have a model like 3, you should have put other, right? And then you might have material criticality, which is usable. We have done it for clients, and it's better than nothing, by all means. You've got the value-based model. Well, you can't take that one because there's not that many, and we know exactly who they are. And then, or have you, completely assimilated your whole plant, and therefore know exactly how many you do. I'd love to get your feedback. Thanks, Lisa. Now, at this point in time, most clients will come back to me and say, Andre, we sorted, man. We've got SAP or Hexagon or Onki or whatever. They cater for it. And I'm going, no, I've looked around because obviously we as consultants would like to support our clients with the best possible solution. And I haven't been able to find one, apart from solving the whole thing, modeling the whole thing. So no. And you can answer this very quickly, very easily, folks. All you need to ask yourself is, if you look at your CMMS, does your CMMS have the capability to model the consequence of a stockout? Not it failing. That's not the same consequence. The consequence of a part not being available. I have not found a CMMS you can model that in. So there isn't a CMMS that can do this for you. It doesn't exist. If I'm wrong, please tell me. I'd love to know. You can help me with my research. So does my CMMS cater for it? Then they'll go, but I have a material criticality. Don't worry. We've got material criticality. That's fine. Our CMMS caters for it. And I'm going, well, you should go back to the first question, because if you don't have that, what is this material criticality based on? It is based on this, which doesn't apply. All right. Or some kind of permutation that someone dreamt up to try and put in there. All right. It might be that material criticality might be a function of the criticality of the asset and maybe the consequence of it failing. But once again, that's not the same consequence or probability that we're talking about here. That would be something more relevant, though, but still not quite as it should be. Now, lastly, guys will come and say, well, the good thing is AI. AI is going to solve all problems. Yeah, I'm sure you've all heard this a lot. I recently spoke to one of the spares managers at a very big refinery, and he was doing his doctor's thesis on this. And I was going, okay, and how's that working out for you? He said, no, it doesn't work. You see, it works for 10 to 20% of stuff that moves. There it works. But it doesn't move for the rest. Why? Because the consequence of a stockout wasn't modeled and therefore cannot be calculated. And this is like, well, then you just model that and then AI can solve it for you. Yes, that is true. That's true. That's like asking AI, what's the circumference of a circle? He will have it and mostly accurate for you, but we know what that is. We don't ask AI. It's a simple model. So how can it optimize the risk if it doesn't exist? Yes, it does apply 5, 10% of your data. That leaves the value model as the only practical solution out there, unless, of course, you want to do a complete simulation, and we can help you with that. So this value-based model, how valuable really is it? What does it bring to the table? Now, this is not a marketing exercise, so I don't want to spend too much time on it. In principle, like all models, you have to understand demand. Or what is the probability of you having to provide this asset? So there is a demand prediction model in there, and there's the spares optimization model. Now we are looking at the order quantity where we need to optimize that. And now we're taking multiple other factors into account, not just the usual economic order quantity calculation, but in principle, we are optimizing that. And that's also then used to determine your service level. Now, this is vastly different. It's used to determine your service level. In all the other models, you pick a service model, right? And if you've got too much stock, then you just reduce that and you reduce some of your stock. But there's no science behind it. All right. So here you take consequence of a stock out and all the other items into account to calculate what is the optimum safety stock level, which is your Z factor, and therefore the probability of a stock out or your service level. All right. So this Pragma value model, in principle, it models the probability of a stock out. It's the probability of you requiring it. And therefore, with that service level, what's the probability of it not being available? It models the consequence of a stock out. And as I've said, sometimes there's no consequence. I find that a lot. People struggle. If something is not in the bottleneck, it's probably not going to have a consequence. Why? Because you've got a stockpile or a buffer or something that's gonna allow you to find that item in time and put it in play. If you can drive out and order it in 4 hours and you've got a stockpile of a day, then you're fine. All right. Furthermore, this value-based model uses value. That's vastly different from all the others apart from Model 6. Right? It uses value to motivate whether a spare should be held or not. So it answers the question, should I hold a spare or not? Secondly, it optimizes the spare min-max levels, when to order and how many to order based on rands, cents, dollars, yen, whatever you use. The optimum service level is the output, not an arbitrary input. Folks, it's a huge deal. If many of the models out there, you pick your service level. So if you've got too much stock, you just reduce that service level and you release stock. But there's no science behind it. You're not looking at the probability and the consequence of a stock out. It recognizes and optimizes spares having difference in consequence to the asset it's linked to. This is a huge issue, and I'm not going to spend too much time on this, right? I can show you examples where a certain motor is held as a spare. This motor is used in 25 different function locations. 2 of them is very critical. And then A criticality. And then there's 5 B criticality. And then there's like 18 or so C criticality, meaning it's not that big a deal if they're not being used. But you see, mostly in engineering, we go, oh, let's pick the highest one. It's very critical. So this motor is very critical. You need to replace it, not taking into account that we have 26 of them or 25 of them in the plant, and they're not all at A criticality. And how do you deal with this conundrum of not all of them having A criticality? It updates the spare criticality models, space criticality model for procurement use based on value. So now if you're saying, I've got this criticality rating, okay, this criticality rating is now real. It's based on actual probability, actual consequence, and more so, if you normally order 3 at a time, and now you're getting to, you've got 3 in stock, now suddenly it consumes all 3 at the same time, even your safety stock, you must be able to recognize that this item right now has got a big issue. It's a lot more important to recuperate those than maybe other items. You want this to be live. Lastly, because it's based on value, it allows you for optimization over and above min-max levels, even as part of our delivery when we get involved with clients. What do I mean by that? You see, when we recommend and say, well, the model says, well, this is your min, this is your max levels. It will also tell you, because it runs multiple different models, it will tell you the biggest difference between these models and therefore where the biggest opportunities are. It will rank them so that you know that if I look more into this specific material item, there is a probability of saving X. And that's the most. You're always going to be optimizing on the most lucrative optimization opportunity. And you're going to exhaust that to a point where the model will tell you that the possible savings that you can achieve now is X. And when that X is too small, you're going to stop saying, well, yeah, we've exhausted this. To optimize that further, yeah. So you're going to save 10 Rand a year. We're spending a lot more effort than what that saving is. So it will direct you to which material items to work on. It will also provide you the input variables in doing so. It facilitates that session, right? So that you can optimize it, make the right decisions, make an informed decision, and it will show you what the value in the output is, therefore how much you're saving and when to stop when it's not necessary anymore. There's no model out there that does this. If I can show you some examples of what we've done, this is a very simple, but if you're all familiar with this ROI type of model, sorry. And here you could see this specific item has 27 million of spares. And the model says that just in holding costs, you can save $543 per year. By the way, that's not 543 that's dollars per year. That's not inventory, right? That is the financial cost of holding the industry. So this is real. Even if you claim just 50% of that and you ignore the transaction cost optimization that you have, therefore ordering the right quantity every time, or if you totally ignore that you will not have stockouts, because this is going to help you with stockouts, because it understands the consequence thereof. So it's going to optimize all three. If you only look at and get half the value of the holding cost, you'll still end up with an internal rate of return of 34%. And that is a very slow release as well. This is modeled going, in the first year you only get 50%, then 70%, 80%, and so continues. All right, so very realistic model. In the very, very least, you should achieve 34% IRR. Something that's a bit more realistic is to say, well, you're going to achieve about 70% of your holding cost. You're going to achieve 20% of your transaction cost, because often clients will say, well, that's not that real money. Maybe I can even agree with that. That's why we only made it 20%. But then there's this risk cost, right? You're not going to stand still because you don't have the right spares. Even if we pick just 1% of that, you're looking at an internal rate of return of 141%. And this is a more realistic view of the value that this can offer. And that brings us to the end, folks. We've shown you that there is issues. We can resolve those issues using the value model. And when using the value model, you'll get your return of the project, and handsomely so. And we'll show you how to solve it. And I haven't calculated all the extensive optimization that you bring about thereafter. This is just first tranche of implementation. I'd like to invite you, if you want to learn more about this and learn more about spares optimization, you can scan that QR code. And we're presenting a 3-day vault, which is virtual instructor-led training. I'll be presenting it myself from the 14th to the 16th of September. You're more than welcome. I'd love to have you there. And there's some of the content that we'll be talking about. First of all, introducing you to spare parts, what does it mean, life cycle costing thereof, etc. We're looking at the fundamentals of spare parts, administration. Remember those two blocks? One says hold the right quantities, min-max levels, and the bottom one is administration. You can't not look at administration, right? So we're not going to spend too much time on it, but you have to get the basics in there as well. Then identification, specification, and classification. How do you think about that? You need to get that right to be able to optimize. Then demand forecasting, important in all the models. In all the models, you need to understand that. And then the optimization, the basic formulas that's used, and ending off with spare parts optimization strategies. There are multiple different strategies that can add value in here as well. And then lastly, how does the future look like? How does inventory optimization campaigns, future trends, how does that look like? I see we've got a question there as well. We're practically at the end, so the question is very, very apt. So folks, you could start bringing the questions. Finishing off, last slide. But coming back to the original two questions, right? So people want us to optimize their spares holding. How many should we have? Should we have the spare? And if so, how many should we have? How many should we order at a time and when? And then also optimizing the spares administration function. Do you have the optimum spares processes, reservations? And both of these are very real. I've come to clients, then we'll do an aim up exercise and we'll ask them, okay, show me your spares and your stock holding. And I'm going, but hang on, you're supposed to have ordered this item. Have you ordered it? No, we haven't ordered it. Well, I mean, what does it help? If you've got the system that supports you, you're supposed to order it, but you haven't ordered it. All right, that's basic spares administration. Clients would come to me and say, Andre, should we first, set the right levels, min-max levels, or should we do the spares administration first? It's a tough one to answer. But see, I always go, it's not either or, it's both and more. You need to solve both at the same time and mature both. But it doesn't help. You're very good at ordering, but you're ordering the wrong stuff. You're very good at receiving, but you're receiving the wrong stuff. And at the same time, it doesn't help. You've got the right min-max levels, but you're not ordering it when you should. So it's not either or. It's both and more. Which brings me to the end, and I'd love to take your questions. You said we'll keep this at 45 minutes and leave 15 minutes for questions, and that's exactly where we are. We've got Wiley, I hope I've pronounced that correctly. Material criticality model looks at asset criticality and considers the consequence of not having the spare part. Indeed, it does. The value-based model, material criticality looks at asset criticality. Yes, that asset criticality is, of course, as I've said, the probability of it failing when you look at MTBF, and its probability of going from shut to shut, and the consequence of that, meaning consequential damage and so forth. The value model looks at the cost of holding the spare part versus not having it if needed. Absolutely. Finance says reduce inventory, and Optimum says don't reduce plant inventory. Combine material criticality to protect rational risk model. Yeah, remember the value-based model does protect you better than material criticality. Because the material criticality model both looks at the same demand, right? So the material criticality and the value-based model, their demand module should look the same. They should look the same. So your probability of requiring the item should look the same. But then understanding how important the critical that item is, that is vastly different between the two models. All right. Material criticality also doesn't take into account that, for instance, this single motor is used in 25 different places, of which 18 of them is not relevant. It doesn't take models like that into account. It simply says, well, I'm going to pick the most important asset to which it belongs, and off I go. And that wouldn't help you either. And most often also, it simply takes on that material as is, meaning you can have a component which is not critical for the item to run, or you could still run it at half speed or at something else. But that isn't modeled in material criticality. Whereas the value-based will allow you to run different models. Thanks for the question and the comment, Wiley. Appreciate it. Folks, just something else, of course, I think there on the public chat, there's the spare parts optimization course that we're running. You're more than welcome to join. And folks, if you want to get in contact to learn more about our model or our offering, please do so. We'd love to support and help you. And also understand your problem and possibly even your counter solution better. That's what we're here for. On Monday, not tomorrow yet, so just give us till Monday. And, it'll be posted and you'll receive the link to it as well. Lisa, I think that brings us to the end of our session today. If there's no other questions or comments, I would like to thank you for joining. It would have been terrible if there's nobody in here. Of course, it's always lovely having you. And please, if you have any other questions or comments, please aim it to me directly. I'd love to well, we as Pragma would love to support you in this. Thanks for joining and all the best for the rest of your day. Thanks, folks.